All right, so what would happen if we apply the procedure that we used for ln of x and inverse tangent of x and inverse sine of x? What if we apply that to a general function f of x? Let's go through that same process and see what happens. So the first step is just to write f of f inverse of x is equal to x, right? Just like we did before. And then we're going to take the derivative of both sides. So dx of f inverse of x. And then we're going to take the derivative of x. Okay. So again, we need to use the chain rule. So when we use the chain rule on the left side, we're going to get f prime of f inverse of x, right? Take the derivative of the outside function, leave the inside function alone, and then we have to take the derivative of the inside function. So we're just going to write that as d dx times f inverse of x, and then that will be equal to 1. So the last step, just like we did before, is we're going to divide both sides by the f prime of f inverse of x, right? So we'll end up with dx, the derivative of the inverse, f inverse of x, is equal to 1 over f prime of f inverse of x. All right, so now we have a formula. So if we know the value of the inverse, and then we know the derivative of the f of x, then we can find the derivative of the inverse without actually having to find the inverse and then take the derivative of it. Okay, so I'll meet you in the next example for an application of this.